Hello and welcome to another IoT Central webinar. I'm David O'Hara and I'm the Managing Director at IoT Central. I'd like to start by thanking Telit Cinterion and Sony for sponsoring this event. This webinar is titled Future-Proofing IoT, Insights on Cellular IoT Strategies. Now, I'd like to introduce today's speakers. Jitendra Vora is Senior Director, Product Marketing and Carrier Relations at Telit Cinterion. And Guy Cohen is Director, Product Management at Sony. Gentlemen, when you're ready, let's get started.
Thank you, David, and hello, everyone. It's great being here with IoT Central. Thank you for being a part of this discussion. So to kick things off, let's begin indeed with a general overview of the evolution of cellular technology and its key trends. So in general, the cellular technology has undergone significant evolution over the past few decades, starting from its inception in the early 80s. A new generation comes every decade and provides new capabilities and technology options. After introducing the mobile internet and multimedia services in the third cellular generation, the mainstream focus has been enhancing performance, increasing capacity, and enabling faster throughputs and data speeds. 4G LTE long-term evolution established various categories, each with distinct levels of performance. The higher category employed, the higher achievable data rate is. This high category's 4G pass aligns with the enhanced mobile broadband (eMBB) use case in the 5G framework, targeting extremely high level of data rate. In parallel, a new branch with lower categories emerged within the 4G domain to address diverse requirements for Internet of Things use cases. It was recognized that such use cases come with distinct needs following by different characteristics and technology KPIs. Given that the quantity of the delivered data is smaller and less frequent, there is no necessity for extremely high throughputs. So instead, the focus shifts to critical aspects of product cost and power savings. Category 1 to Category 3 and Category 4 in the 4G LTE space follows with the 5G NR, new radio, RedCap, reduced capability technology in the 5G area to meet such kind of use cases. But the real focus on communicating things came with an introduction of two new categories in the 4G area, LTE-M and NB-IoT. These categories are exclusively designed for IoT devices, offering a full optimization for the IoT use cases. Looking ahead, the 5G massive IoT space continues to base on the LTE-M and NB-IoT, which are therefore expected to exist up till 2040 and above. It is designed to support a massive number of connected devices such as sensors, cameras, and other Internet of Things products. The MIoT solutions prioritize cost effectiveness, power efficiency, and the ability to support extremely high device density. I'll be happy now to pass it over to you, Jitendra, to share more insights on the cellular trends. Maybe a question, Jitendra, how do you perceive the distinctions among cellular categories? How do you position LTE-M and NB-IoT in relation to Category 1 and below?
Well, thank you, Guy. First of all, it's a pleasure being here with you, David, and IoT Central. In fact, I've been looking forward to our conversation and to kind of share Telit Cinterion's global view on the progress and maturity of cellular IoT networks. So let me kind of address the topics you just kind of mentioned. So let me start off talking about LPWA by highlighting what NB-IoT and Cat-M have in common. I see customers selecting either Cat-M or NB versus Cat1 or Cat1 bis primarily for three types of situations, right? The first is they have a battery-powered application or device, and those type of customers gravitate towards NB-IoT or even Cat-M. It really depends on the customer as well as the region where they're located. The second thing is if they want to benefit from some of the features that are available in both NB and Cat-M1, such as EDRX or power saving functionalities. And third is if they require good coverage, then the enhanced coverage feature is available on both NB and Cat-M, but not on Cat1, right? And I'll talk a little bit more about that shortly. So now let me talk a little bit about the difference between NB-IoT and Cat-M1. So NB-IoT is mainly for static use cases, right? So an example of that, customers that gravitate are of static use cases, gas and water metering. And for like battery powered applications where data needs to be transmitted very few times in a day, thus a low reporting rate. When you think about NB-IoT from a data rate throughput perspective, the uplink is about 160 kilobits per second, and the downlink is about 120 kilobits per second. So just to be clear, it's not just about the low throughput desired by NB-IoT, but also low reporting rate for the data as well, right? Some of the applications or verticals that we see from an NB-IoT perspective are smart metering projects, such as gas and water and waste management, smart lighting, smart agriculture. By that I mean sensors to measure the humidity, for example. But I want to clarify that some customers may also prefer Cat-M1, depending on the coverage in the region where they want to deploy. So, there are some caveats to that. For example, in the US, lots of gas and water metering companies and even electricity, it is on Cat-M1 as the coverage in that technology has been really good for a very long time. Europe, on the other hand, has been more NB-IoT. Now let me talk a little bit about LTE-M. Cat-M1, on the other hand, is much more flexible as it allows for higher throughput for mobility use cases. The data throughput on Cat-M1 is uplink can be up to 1 megabits per second and downlink up to 588 kilobits per second. Applications for Cat-M1 are smart metering, electricity. It can be good for trackers such as consumer trackers, pet trackers, vehicle trackers, for asset tracking, e-health, smart agriculture. So now if I was going to touch about Cat1 bis, there's some pros for Cat1 bis, pros that compare it to Cat-M1, and there's some pros of Cat1 bis compared to Cat1. So let me talk about the pros compared to Cat-M1. Cat1 bis has a higher data rate compared to Cat-M1. There's greater worldwide Cat1 coverage. Cat1 bis and Cat1 are on the same network. They're deployed just about everywhere. One more pro is that many Cat1 bis chipsets support voice or VoLTE in many parts of the world. It's not available in the US yet, and it still hasn't been proven. So until that gets done, it's going to take some time for the US to kind of accept that. Now let me highlight the biggest pro of Cat1 bis, this time compared to Cat1. It's a price issue, right? So cheaper from a module perspective compared to a Cat1, since there's only one transmit antenna. Now the cons of Cat1 bis, it has to do with the extended features like EDRX and PSM. Yes, they're supported on a Cat1 and Cat1 bis standards, but not yet deployed by operators. Especially EDRX, which is very important for battery-powered devices. Therefore, battery-powered applications such as NB and Cat-M continue to be the best choice, as I talked about earlier. Because MNOs have deployed EDRX and PSM and NB and Cat1 M1 networks. So another con I wanted to highlight is with Cat1 bis is power or current consumption is higher on Cat1 bis compared to NB or Cat-M in power savings mode. When it comes to data throughput and the data rate for Cat1 bis, uplink is 5 megabits per second, downlink is 10 megabits per second, exact same as Cat1. Applications for Cat1 bis, security panels we're seeing, telematics, asset tracking, just to kind of name a few. Bottom line is when it comes to Cat1 bis, MNOs are treating Cat1 bis equally to Cat1, with the only exception of VoLTE, right? MNOs don't care about the inefficiency in terms of network capacity. End customers don't care about network efficiency, as this does not affect the device performance at all. In fact, it is an issue only for the MNOs, but like I said, they don't appear to care at this point. Now let me kind of close it with Cat1. The pros of Cat1, again, great worldwide coverage. It's deployed everywhere. It's the best choice for the devices that require voice or VoLTE, mainly because it's been proven. And it also has a dual antenna option. And now you're starting to see PSM support in some Cat1 networks. The cons when it comes to Cat1, highest in terms of cost, and it also requires more space on the PCB. The data rate, very similar to Cat1 bis, uplink 5 megabits per second, downlink 10 megabits per second. Use case, voice, data and mobile applications, security panels, telematics, asset tracking, et cetera, et cetera. So let me stop it there. I know I mentioned a lot, Guy, as you kind of stated in the beginning. I kind of walked through the different technologies. I kind of talked about the pros and the cons and the throughput and also the use cases. So I'm not sure if you have anything else to add there, Guy.
Yeah, thank you, Jitender. Very interesting, and you clearly outlined the differences between the categories and their respective products. Yeah, as you said, regarding the lower categories, there are cost-related advantages for the lower categories. Maybe to add, I think that from chipset perspective, LTE-M and NB-IoT also offer the flexibility to work many times with a single hardware SKU that can support the overall multiple frequency bands and carriers using a single hardware design. In some cases, LTE-M also has the capability to enhance coverage in different scenarios due to advanced coverage techniques. I think that we probably together we receive many times inquiries about the better choice between CAD-M and NB-IoT, at least in our side. And I think that practically in many cases, we will see a big advantage of supporting both modes on the same device. This will enable a dynamic selection of the technology, eventually based on the application needs and actual network coverage requirements. So this is another important item maybe to add from my side. Jitender, I think that if no further comments, we shall move to the next part.
Sure. Yeah. No. So I'm glad to hear some of your inputs, Guy. So let me kick off the next topic, which has to do with growth and maturing of coverage of cellular IoT networks, right? So I wanted to kick off this section by talking about how LPWA technologies have evolved. During the early days of LPWA deployment, which again is NB-IoT and CAT-M1, different countries took on different approaches. Now the strategies have changed. In the beginning, some countries were going down NB-IoT while others were going down CAT-M. For example, the US started off with CAT-M primarily. CAT-M1 was not the true global technologies like a CAT-1, mainly because CAT-M1 was not widely deployed in China, in Europe, or in Latin America. On the other hand, many countries, within Latin America, European-based countries, and China were aggressively deploying NB-IoT. Now the strategies have changed. Most operators are activating the second technology in the network. So if they started off with CAT-M1, now they're activating NB and vice versa. As a result, the coverage footprint of the two technologies has continuously improved. Now, some of you may be wondering, well, what's next with LPWA? The good news is there is no news, right? So LTE-M and NB-IoT are the technology of choices for LPWA use cases and will not be replaced by another new technology in the future. They are the cellular LPWA technology for 5G. This has been made clear by 3GPP and by operators as they are committing to support LTE-M and NB-IoT into 5G. This is why we partner with Sony and their leading next generation, Sony Ultra 1350 chipset within our NB310 M1 module, right? So I guess my message to the device manufacturers that are kind of listening to this is you should have no worries deploying these technologies in their devices. These are here for the long term. So, let me kind of stop here, Guy, and turn it back to you to talk about the growth and maturity of coverage from the Sony perspective. Maybe you can share some more details on your 1350 chipset, anything interesting from a roadmap perspective that will help with the growth in 2024, 2025. For example, I know there's a lot of buzz regarding ISIM and NTM. Maybe you can touch upon some of these things.
Yeah, sure. Actually, I would be glad to provide more insights into the 1350 in this context. Generally, the R1350 is our third generation cellular IoT chipset, specifically developed to meet the evolving demands of the cellular 5G massive IoT market. This SoC system on chip features ultra-low power consumption across various modes, including the BSM and EDRX modes, Jitender, you just mentioned before. And this significantly increased the longevity of battery-operated devices. You also attach the longevity aspects and the perception of CAT-M and NB-IoT as part of the 5G ecosystem and space. The 1350 has different functions, integrated function. It has an AI engine for edge processing. It comes with the indoor and outdoor positioning technologies bundled with a sensor hub, which collects data from sensors while maintaining its ultra-low power and very high level of security. It is a highly integrated solution supporting LTE-M, NB-IoT, as well as short-range radio for sub-gigahertz and 2.4 gigahertz protocols. Yeah, so it came out with capability to support 3GPP release 14 and diverse set of feature set to improve power consumption and allow utilization of the different radios. But as you mentioned, Jitender, our future plans include deployment support for more advanced 3GPP feature set. It includes release 15 and release 16, also release 17 down the road. And we also intend to introduce support for the commercial integrated SIM and also NTN, non-terrestrial network capabilities and support down the road in the future. We are very pleased that Telit has chosen to incorporate the R1350 in their latest models. Telit leads the way in collaboration with multiple device manufacturers to leverage this unique technology and allow and offer new use cases and application within the IoT space. Jitender, any further comments or topics to raise from your side here?
Yeah, I mean, I guess before we move to the next section, I think you mentioned a lot of items that you have on the roadmap, right? Today is release 14, then you're gonna have features from release 15, 16, 17, NTN, ISIM, et cetera, et cetera. The good thing is that the hardware from a module is ready, right? So now everything going forward is gonna be more software. So, this is a module that's gonna be coming out. We're gonna be certifying it in the next, few months, few weeks. So that's a good thing. So that's the only thing I want to add. But if you're okay, Guy, I can kick off the next section.
Yeah, sure. This was a very good point. Everything is capable in silicon hardware level, and these are software-oriented features that will be supported in the future. And yeah, I think we can proceed to the next section then.
We're on a roll, Guy. We're on a roll. This is awesome. So let's move to the last topic, which is how to monetize cellular IoT use cases requiring low bandwidth and permanent roaming, which is opposite to the current broadband demand, right? So from our perspective, from a Telit Cinterion solutions company perspective, I wanted to make 2 points. So first, the best way to monetize cellular IoT use cases is by scaling the volumes, right? You really need to achieve the right scale to justify it. For the vast majority of device vendors, it's not a business of few connections. It must be millions of connections before you start seeing the return on investment. Secondly, it's not only about selling modules and then connectivity, but also about providing other services on top of pure connectivity. Possibly managed connectivity to those millions of devices. For example, connectivity management services, also device management services, and remote management services in order for customers to maintain control, of a fleet of devices deployed in the field. For example, knowing what percentage of those devices are down, how many remain connected to the network. So we're talking about monitoring the SIM status, the SIM data consumption, the same for devices being able to run over the air campaigns. So if you need to roll out new features into the SIM card or even fix problems in the field, the only way to really be able to offer more than just pure connectivity is by supporting more and more advanced software inside the modules. That are not, these modules are just not brainless piece of metal, but they're quite intelligent, very similar to smartphones. Guy, I think it would be interesting, maybe for you to shed some light from a Sony perspective on this topic as well.
Yeah, thanks. These were insightful inputs and very interesting. I think looking, the cellular IoT from maybe a different perspective, I would also add that the monetization of cellular IoT cases will heavily rely also on the ability to establish end-to-end solution and leveraging technological advantages to optimize eventually the total cost of ownership. Analyzing the benefits of cellular IoT, we can suggest to categorize them into operational and technological aspects. From an operational standpoint, cellular networks provide inherent benefits by offering reliable and secure communication with global compatibility. Leveraging existing cellular infrastructure eliminates the need for additional investments in building new networks, which facilitating a quick and easy deployment. On the technological side, selecting the right chipset and module is highly important. Key elements like ultra-low power consumption, integrated functions within a compact size, and the capacity to achieve extensive and improved coverage are heavily influenced by the lower-level solution. The performance is largely defined and shaped by the solution's architecture, design, and algorithms. As previously mentioned, the various technologies and functions go beyond today the cellular modem, and all are integrated into a single chip with a compact footprint. And this integration simplifies the solution design and engineering, leading to a reduction in the solution size and eventually improve the cost efficiency. Collaborating with the right chipset and module vendor to leverage these benefits will enhance overall cost effectiveness and offerings. This collaboration, I think, is crucial for achieving the necessary scalability and effective monetization of the IoT solution use cases. Jininder, so if you don't want to comment further, I think that we can ask David to take now the lead, and maybe we can move to the final part of this discussion.
Yeah, we can move to the next or final closing part with David.
Jitender Guy, thank you very much. That was extremely insightful. I think everybody watching really got a lot out of that. You really helped clear up and demystify a lot of the technology, the whole cellular landscape. So thank you for all of your knowledge and insights. So as I was listening, I certainly jotted down a few questions. And Jitender, the first one I have is for you. So Telit as a solutions company, for example, you provide both the module and you're also an MVNO. Can you talk a little bit about the advantages of working with Telit as MVNOs versus MNO?
Sure. Yeah. Thank you, David. That's a great question. I actually, we are clearly a solutions company. We work with, in fact, I work a lot with the MNOs, as a module vendor. We also have an MVNO offering where we partner with MNOs in order to offer better service to our customers, right? As a result to our uniqueness, being both, there are some advantages working with Telit as an MVNO. So if you work with a single MNO, you may be tied to a particular technology that an MNO strategically decided to deploy. Because as I mentioned before, now most of the operators are deploying both Cat M1 and NB. But there are differences. Some operators in some countries only have one technology activated at a time. So instead, with the MVNO, one of the advantages of working with an MVNO such as us is you have partnerships. We have partnership with multiple operators. So MVNOs can complement their offerings in terms of available technologies in the different countries by putting together what they get from different MNOs. So you are getting much more flexibility because you get multiple options compared to working with a single MNO. Also, keep in mind, MVNO's core value proposition is to reduce complexity and make it simple for customers. So customers don't have to go sign contracts with different MNOs in different countries. They have one single interface, one single SIM card, one single contract, connectivity management portals. It's just one for global use. They have a single aggregator, basically. So our customers around the globe are attracted by how we made it simple for them. So that's kind of, I guess, that answer to this first wonderful question that someone asked. So back to you, David.
Great. Guy, one of the questions I had when I was listening to you, I was curious, what factors should be considered when selecting between eDRX and PSM power modes?
In practice, the effectiveness of power modes largely depends on the specific use case. The key consideration lies in the device's reachability requirements. I would say that PSM is better suited for applications that can enter extended sleep periods without requiring frequent listening or triggering for communication by the network side. In such scenarios, PSM ensures a minimal power consumption by allowing the device to enter a deep sleep state, leveraging the fact that the network context information is typically not retained in memory. and this leads to low power consumption at the chipset level. However, if the device requires more frequent wake-ups, power consumption may increase, and EDRX could potentially yield better results. EDRX would be better suited for applications that need to remain in listening mode and respond quickly to the network paging signals. Optimizing power consumption sometimes involves combination of both modes throughout the device lifetime to meet the application power consumption and battery lifetime requirements effectively.
So the chipset perspective guarantees that PSM provides improved power consumption?
Again, it depends on the use case. So in specific use case, PSM would provide a better power consumption. EDRX would be suitable to other ones. And eventually, it also be good to combine both modes within an overall device product application and overall lifetime.
Well, we've covered a lot here. I think right now it would be great to see if you guys have any final thoughts, anything that maybe wasn't covered that you'd like to share with the audience. And while we're already speaking with you, Guy, let's have you go first.
Yeah, David. So I think we've discussed cellular trends and delved into the cellular IoT field, highlighting some of its strong advantages. Perhaps two takeaways from my side. So firstly, LTE-M and NB-IoT categories are purpose-built for IoT devices, maximizing cost and power efficiency. Recognized as 5G-ready technologies, they will continue to be supported in the 5G landscape. And a second thought or second takeaway emphasizes the significance of collaborating with the right chipset and module vendor. This collaboration unlocks potential technological benefits and facilitate the way to optimal end-to-end solution in the IoT space.
How
about from your side, Jitender? Any other questions? Anything else that you want to cover?
Yeah, no, I appreciate that. Once again, number one, it was fun having this discussion. I'm sure people will find it useful. At the end of the day, I really enjoy helping customers, choosing the right technologies. We talked about NB-IoT, Cat M1, Cat 1 Biz, Cat 1. The technology should be based on the application, the use case, and so on that we talked about, right? Obviously, we have lots of experience globally, as well as the relationships globally. So please don't, hesitate to reach out to us or Sony for any guidance, so we can help you, so we can help guide you. So, I just wanted to say thank you for everyone that's, spending the time kind of listening to this recording. Back to you, David.
Great, gentlemen. Well, this brings our webinar to a close. I'd like to thank both you, Jitender and Guy, for being with us today and for your insightful presentations, and especially thanking Telit Cinterion for sponsoring today's event. You can view more webinars at iotcentral.io. Thank you for watching. Thanks, guys.
Thanks.
Thank you.